In this video, I will show you how the inductance and the capacitance influences the buck converter's behavior. So I think in order to look at this, we should go into a simulator to have a look at it. So I've made a basic simulator here. So if we have a look at this, all you need to know is that the input voltage is 100, and then the output voltage is 50 in this case, and that the switches here are controlled so that we get the desired output voltage. And then we have an inductor, capacitor, and then we have a load and a switching frequency for the switches. Actually, I will use this standard type where we have a diode here instead. The behavior is almost the same. The only thing is that we would not be able to have a current flowing in the opposite direction as we have for the bidirectional one. So that is why I choose to go with this one. So the controller is not very interesting here. We don't want to look at it, but when we simulate, we want to do some sweeps. We will sweep the inductance, capacitor, and the load. So then we can run it and have a look at what happens. So these are just two different modes. So this is when it's continuous and this is when it's not. So we can just remove this one. So if we first look at how the current behaves with the inductance, then we can see that when we increase the inductance, you can see that the current ripple decreases. When I change it, the axis is the one that changes, nothing else. So you can see that here it's about maybe 5 in a ripple. And then if we increase it, we get maybe 3 in ripple. So by increasing the inductance, we see that the ripple of the current decreases. And this is very good because this reduces noise and also it reduces the wear on the components inside the buck converter and also around the buck converter itself. And then if we look at, and the inductance also affects the output voltage. Now in order to analyze this, I think we need to add a cursor. So let's add one at a top and then one at a bottom. And then we get the values down here. Yes, so now we have a positive value for this. So you can see that at this state here, we have a 0.03 in voltage ripple. While if we increase the inductor, you can see that we get a 0.014 instead. So by increasing the inductance, you reduce the voltage ripple. Now if we put this back to 100, then we can have a look at what happens when the capacitor changes. So you can see that the capacitor basically doesn't change the current. So if you look at the current, the axis doesn't change at all. While you can see that it changes the magnitude of the ripple for the output voltage. So here if I drag it all the way down, you can see that I get 0.5. Then if I increase it, you can see that I get 0.17. So by increasing the capacitance, you reduce the ripple of the voltage. And reducing the ripple of the voltage is good in the same way as it's good to reduce the ripple of the current, because it reduces the wear on the components, both inside in buck converter and around, and also reduces noise. So in my next video, I will explain to you how you can design it in more detail. So now I just explained the intuition behind it, but in my next video, I will explain how you can put exact formulas on the inductor and the capacitor and calculate them. And if you're interested in this course, you can go to the link in the description. And if you're interested in this simulator, it is also in the description.